Hello, welcome back to Python Challenge for All. Okay, let's see where we were last time. So last time we try a group of approaches, which is collectively called best first search, okay, to solve 8 puzzle problems. So yeah, we anyway tried uniform search, which sorts the candidates in the open list according to the distance from the start using sort open L, right? So it actually, this is, in this case, as I said, uh, exactly the same as breadth first search. So let's make a variation of best first search today in lesson 84, greedy search using heuristics, okay? So what is greedy best first search? Let's see the Wikipedia. So here, let's see. No. It says best first search is a collection of algorithm, and then what is greedy search? The greedy algorithm is any algorithm that follows the problem-solving heuristic of making the locally optimal choice at each stage. So, of course, um, generally, we don't know what will happen in the future. So we don't, yeah, in the problem solving as we are trying, of course, we are trying to solve the problem because we don't know the exact route to the goal. So in this case, we will use the seemingly optimal choice to sort the candidates. Try first the locally optimal choice at each stage. Here, locally optimal meaning seemingly nearest to the goal. Okay, then how we can estimate this seemingly nearestness or distance to the goal. So here we use the heuristics to evaluate the goodness of each choice. So then what is heuristics? Okay, heuristic. In computer science, heuristics is a kind of approximate solution. Yeah, approximation of solution. So here, let's try anyway. One heuristics, H1, number of misplaced panels. So let's see in this case. So if the present state is here, okay, right? Uh, what what do I mean by the number of misplaced panels? So this 7 is misplaced, not in the correct position. So it's 1, okay? 1 here, but 2 is in the correct position, so 0, okay? 4 is in wrong position, 2, so 1, 2. 5 is in wrong position. 3, 6, 1, 2, 3, 4, 5, 6. 6 is correct position. So 0. So let's count 1, 2, 3. 1, 2, 3. 8 is in wrong position, so count it. 3 is in wrong position, count it. And 1 is in wrong position. So in this case, there are 2 correct cases and um, 1, 2, 3, 4, 5, 6. 6. Okay, 6 misplaced positions. So this 6 is H1. Okay. So how can we calculate the H1 value? So let's go back to the So here, first the number of misplaced panels. We will evaluate this number by evalstat function, okay? Sort using this score and try the smallest. So, okay, let's implement eval score, okay? Maybe we can save as EL0AD4, okay, greedy search. Okay, so here, last time we used here, okay, we used this G1 value, G value to do the sorting. So in this case, let's define a function to count the number of misplaced boards. So eval stat, eval score, eval stat, okay? Given the state, it will evaluate the number of misplaced number, which is h value, is kind of sum of, say, ones in, let's see, how can we do this? Sum of ins for, let's see, ni in range from, say, position 0 to nn times nn, if the, okay, let's try this way. Okay, for, okay, let's see this. Okay, maybe let's write this way. So for I in, if, let's see, maybe I is fine. Okay, so in that state, it should be the index -1. That's the correct position. So it should be I in range. If stat I, if that's 0, let's skip it. And if that's not 0, and if that's not I -1, n plus 1, okay, I plus 1. Yeah, this is correct, right? If I, it should be 1 I plus 1. That's the correct position. In that case, that will be counted as 1. Otherwise, it will be 0. So maybe we should write this way. Okay, let's change this. 1 if this, else 0. For I in range n to n. So this should be fine to evaluate if that's fine. Okay, and that should give the h val. And using this, we will return h val, and then, okay, and use this score and try the smallest in sort open L. So it will be like here, instead of using g val, we will use h val, which is evaluated as, maybe we can write this way to make it clearly. So the current state is at the end of the path, the last element in the path, right? So it will be stat, and there we can eval stat and give that stat, of course. And then the new value should be, instead of g value, we will sort by h val. Okay? Of course, we can check the h val each time we try so that it works fine. But yeah, believe me, it should work this way. So let's run and try using this value. Okay, let's try. For example, given at the, okay, this problem, okay? Let's try S. Okay, done, 10 steps. Let's try this. Seems fine. Okay, N, S, 11 steps. It's working, and seems fine. N, S, 29. This is some strange. Maybe, okay, it says it's solved in 29 steps, but is this wise or is this optimal? Let's try this. Seems this is far from optimal. They are doing the same movement again and again. So it seems this is not optimal. Yeah, you can try many other things to see, this is good enough. But N, S, 2 steps, N, S. So in some cases it works, but my observation is that seems very good, but often not optimal. Okay, so maybe think about trying another heuristics. And that's homework for next time. Another score, H2, total Manhattan distance to each desired location. Do you understand this? In this case, we will think, for example, 7, okay, this one, this should go to 1, 2, 3, 4, 5, 6, 7. Go to here, right? So the distance of 7 is now 2. 2 is in correct position, so the distance is 0. 4 should go to here, right? So the distance to the desired position is 1, 2, 3. And 5 needs to move 1, so it's 1. Like that. Okay, 6 is in correct position, so it's 0. 8 should go here, so it's 1. 3 should go here, so 1, 2, 3. And 1 should go all the way up to this position. So 1, 2, 3, 4. So the total of these red numbers are the H2. So can you try this and implement and check yourself? That's homework for next time. Okay? Hope we can meet next time with this solution and further better algorithm to solve the puzzles. Okay, so that's all for today. Be sure to come back and let's meet again. Bye bye.